MCV4U1 Chapter 4, Session 1. In this session, we are going to work on review of prerequisite skills. In order to be able to do well in this chapter, we have to know how to find the x-intercept and the y-intercept of the graph of a function. To find x-intercept, we set y to 0. X-intercept is the point of intersection of the graph of the function with the x-axis. To find y-intercept, we set x to 0. We should be able to find the horizontal and vertical asymptote of irrational functions. To find the vertical asymptote, we set the denominator of the function 0. And we make sure at that point for x's we find the numerator is not 0. In other words, we are looking for x's for the value of x, let's say a, when x approaches a, f of x approaches infinity. To find the equation of horizontal asymptote of a rational function, we find limit of f of x as x approaches infinity, and if we get L, that is the horizontal asymptote. We know if f of negative x and f of x are the same, function is called even. And for even functions, y-axis is the line of symmetry. And if f of negative x and negative f of x are the same, function is called odd function. And for odd functions, the origin is the center of symmetry. We should be able to work with inequalities very well in this chapter. We need to draw the sign chart for derivative of a function. Whenever derivative is positive, we'll see function is increasing, and whenever derivative is negative, function is decreasing. When we say a function is increasing on an interval, that means the graph of the function climbs on that interval. Function is increasing when x is between a and b. On the other hand, when we say the function is decreasing, that means the graph of the function in that interval is falling. In order to do well in this chapter, we should be able to solve simple equations and inequalities, know how to sketch the graph of the basic functions, and apply the transformations. In grade 11 and in advanced functions, we worked with functions like y equals x, y equals x2, y equals absolute value of x, y equals x3. We saw the graph of y equals root x. We also worked with the exponential functions. We needed this in the next chapter. We know the graph of y equals 1 over x, the reciprocal function. The graph of 1 over x to the power of 2, the reciprocal of x2, and we need to know how to find the asymptotes that we talk and the rules that we worked on derivatives. So far we learned The derivative of a constant is 0. Derivative of mx plus b, a linear function, is m. Derivative of ax to the power of n is nax to the power of n plus n minus 1. If a function is addition or subtraction of two functions, the derivative would be derivative of first function plus or minus derivative of the second function. We learned product rule. Derivative of uv is u prime v plus v prime u. We learned the derivative of u over v, quotient to u rule, u prime v minus v prime u over v2. We learned the derivative of a to the power of n, an u to the power of n minus 1 times u prime. We learned the derivative of 1 over x is negative 1 over x2. Derivative of square root of x is 1 over 2 root x. In all these formulas, u and v are functions of x. In order to work better in this chapter, we work on the following questions next session. Page 162, question 1, part C and D, question 2, part B and C, question 3, part A and D, question 4, part B and D, question 5, part B and D, question 6, part B, question 7, question 8, question 10, part A and C, question 11, part A, B, and C, and question 12 for same functions in question 11. Thanks for watching.